Hello, and welcome to another episode of the AgNext Podcast, where we are always excited to tell you what is next from AgNext. Today, we are excited to speak with Dr. Sara and Dr. Eduardo Paula about in-vitro research. Let's get into it.
Welcome, Sara. It's great to have you back on the podcast. We appreciate you coming.
Absolutely.
Eduardo, you're new to the AgNext podcast, so we would love for you to take a minute to introduce yourself so our listeners have some background on who you are.
Okay. Thank you, Kim. Yeah, very excited to be here. 1 year ago, I was preparing to get hired by AgNext, and I was watching all the podcast, and being here today is very excited. Thank you for the opportunity to talk about the In-Vitro.
Well, welcome, and thank you for coming to our team.
Yeah, thank you. I'm original from Brazil, and I have a background in animal nutrition. I got my bachelor and my master at Maringá State University, where I work with feed additives to feedlot cattle. And then I got the opportunity to first come to US to do internship during my master there. And then I met Dr. Antonio Faciola, and I got opportunity to do my doctorate with him at the University of Nevada, Reno. Then I work with their cattle nutrition, and I started working with In-Vitro. That is the main topic of today that we are going to talk more. And then after my doctorate, I did a 1 year postdoc at the University of Florida, work with sorghum and corn silage with Dr. Ferrareto. Then I went back to my home country to lead a ruminant nutrition lab there. And one of my missions there was to develop 2 in-vitro systems there that I learned in the US. Then I went back, was a 5-year project, very, very nice. I did a lot of studies evaluating feed additives to improve animal performance and health, and also to reduce methane emissions. We did a lot of screening of those feed additives in vitro, and then the ones that work we try in the feedlot in vivo, like in a practical situation. So after 5 years there, I decided with my family to come back to US, and then I saw the opportunity at AgNext, and I look at the job description was pretty much what we are doing in Brazil. And then I decided to move back, apply for that position, and I got hired. And it's about 1 year, 11 months that I'm here. It's been amazing. And around here, one of my first mission, when I asked it to Sara, what we want from what can I add to the team, she said, "What about in vitro?" I said, "Well, let's do it." But at this time, I want to do some things that I wasn't doing in my former lab, like measure methane in real time, and also to do more microbiome stuff using this unique technique, like in vitro technique, to better use the system. And here, methane for us is a big part of that. And then she said, "Okay, I'll give you all the support that you need. Just let me know and let's do it." So one of my job in the last 10 months is being try to find, based on my experience, what would be the best in vitro system for us. And other things that I'm doing here that's really exciting, like writing grants, mentoring students, and support all the feedlot research and all the research that the team is doing. So yeah, was a minute, but just did a little bit more. But
thank you, Eduardo.
Yeah, that was my journey until I got here.
We are very excited to have you in the podcast and also in the team. I don't know how many times you've mentioned the word in vitro, right? We've said that's what we are going to talk about today. But for the listeners who might be hearing in vitro for the first time, can you please describe what is an in vitro system in research?
Yeah, that's a very nice question. In vitro, like from Latin, means in glass. So basically what we do in the lab, we try to mimic in the lab a living process that happens in a living organism. In the ruminant nutrition world, we have the rumen that is very important for the ruminant nutritionists, and is that where the animal gets all the energy that they need. So what we try to do with the in vitro in our world is to mimic that organ or like the piece of the animal in the lab in a more controlled environment that can help us to understand what is happening in the rumen and how we can apply that to the field. I'm sorry.
Yeah. That's cool.
That's great. So there's some clear advantages to in vitro systems. What are those in comparison to those in vivo or live animal projects?
Yeah, that's an excellent question. And in my view, one of the main questions is to reduce experimental cost and live in a world that
it's glass.
It's glass.
Yeah, it's
and
glass.
Yeah, it's very hard to get grants and in vivo experiment nowadays is like crazy high expense. So if we can try to first do in the lab before going to the field, that's one very advantage of that, because in vitro we are going to use much less animals. For example, in one of the systems that we are going to have here, we would simulate like 18 animals at the same time.
Wow.
And like if we do that in vivo, would be like 6 months trial. We can do in 2 months. And instead of feeding the animal 10 kilos or 22 pounds per day, we are going to have like 1 grams per day. So the amount of money that we can save on feed cost make open a lot more opportunities to go first in vitro than in vivo. Also, here at AgNext, we try different compounds that can manipulate the rumen and can improve animal performance, can reduce methane. But sometimes, if we never try that in the animal, we don't know if this will be harmful for the animal or what is the best amount that we should provide to the animal. So the in vitro comes in play to be our opportunity to do in a faster way, in a cheaper way, and preserving the animal welfare, that we can test that in the lab and then see some indicative that has a potential to be tested in the field, and then we can invest more money. But before we can do that screen, also we can do a lot of microbiome studies, try to understand how that compound is changing the rumen, and can try to understand how is decreasing methane and or improving some acids in the rumen that will make the animal more efficient. So doing that in the lab before going to the field, it's a really nice tool to use that system.
So basically it's cheaper, faster, and you can try different things that you before trying to the animal, right?
And also better understand what's going on in the rumen in a more efficient way than going to the field, like doing animal surgical procedures to the animal to assess the rumen. You can do first in the lab
before going there.
Yeah.
Eduardo, I have a follow-up question. So in these in vitro systems, how sure are you of the results? So why wouldn't we just always do things in vitro if they're faster, cheaper? What was the other one you used? Safer, safer, better for animal welfare, etc.
Yeah.
How sure are you of the results? And then why do we still need, or do we still need live animal studies?
What are the advantages, but what are also some challenges?
Yeah, thank you for the question. And I think that's the most question that I receive when I'm doing some in vitro presentation. I used to say that if you want to use the in vitro to explore 100% that is there to the field, you are not using the in vitro in the right way.
Okay.
So because it's like if you take, we are isolate the rumen in the lab, but we don't have all the animal organism, all the feedback, all the interaction between organs. So it's hard to have the same response.
Okay.
But if you want to know if one diet is better than other, for example, if additive is better, adding additive not adding, it's going to give you an indicative that is worth to test or not.
Okay.
For example, I did in Brazil about 5 trials with different feed additives, looking at different doses and different diets, how the potential to reduce methane. Usually when we observe in vitro methane reduction of 40%, and then I had the opportunity to test in vivo, we would observe about 15-20% reduction. So I cannot say it's the same response, but usually the feed additive that worked in vitro will give some response in a lower magnitude, but show you if it's worth to go further or not and invest more money on that.
Yeah, so a real practical tool to some complex research questions.
Yeah.
And screening process, right?
Yeah, love the screening idea.
Yeah.
And also like for proof of concept trial, like in my doctorate, I was testing at that time canola meal for dairy cows. And we have some in vivo studies showing that when we replace soybean meal with canola meal, the cows were producing 2 pounds of milk per day more compared to the soybean meal. And most of the case, the cows were eating more.
Okay, sure.
So with the in vitro, we have all the reactors or the rumens in the lab with the same amount of feed, the same passage rate, and we isolate the intake part and also the post-rumen part. Let's see if there is something in the rumen that is showing us that the response in increasing milk product is coming from the rumen or is the intake or other thing. And we showed that in the rumen was nothing was happening, like improving volatile fatty acids, microbial protein synthesis. And then we conclude that like the effect of canola is not on intake and not in increasing microbial protein synthesis, and it's supposed to be other things. And then other research groups did other research, and they found out later that the amino acid profile that was escaping the rumen and being absorbed was greater, like more methionine in canola meal than soybean meal post-ruminal. And that piece that we isolate, we just show that it's not the rumen. So go look to other
look
things.
somewhere else.
So those are another ways that we can use the in vitro to apply that in the field.
That's pretty cool. So I will give you a break. I'll ask Sara a question now. You mentioned in vitro a lot. I think probably the second word that you've said more so far is it's rumen, right? So basically what we are trying to do, Sara, is like mimic a small rumen or small animals. So the question, why is it important to study the rumen now? So if we talk about the animals, we want to mimic the rumen. Why is it important to study the rumen?
Yeah. So as Eduardo kind of nicely highlighted, right, this is just looking at that one component of the animal, but it is a really complex component of the animal, and it's one that we're interested in from environmental perspectives, but also, as Eduardo mentioned, right, from a standpoint of, well, the actual productive outcomes of the animal. A lot of it depends on what's happening in the rumen. And of course, what's unique about the rumen is because it is filled with trillions of microorganisms, and they're all acting as their own complex ecosystem itself. And so that makes being able to isolate and just look at that component and look at particularly the screening process is what we're really interested in, is really valuable, right? To more isolate that really complex system and try to break it down into its more component parts, if that makes sense. So that part is what's really interesting from that standpoint. And then again, scaling it back up to the whole animal, of course, the rumen is where the methane is being produced, where the feed is being broken down at first, right? And so important for what the productive outcomes are of the animal, but also the environmental outcomes.
Excellent. So this whole fermentation chamber that
Yes.
makes cattle such a unique animal.
Yes.
That's basically what we are trying to
Exactly.
replicate, I would say, or mimic, or
Yes, exactly.
Yeah, so clearly in vitro is a crucial component to the research that we can do at AgNext and will really lend itself to our future research. Eduardo, can you walk us through the different in vitro systems and what you've chosen to build at AgNext and maybe why you've chosen that particular system for the team at AgNext?
Sure. Yeah, so in the in vitro world, we have different systems. It's a methodology and we have different techniques. So we can say that we have batch culture. That is the simplistic way of mimicking the rumen. It's like a closed bottle. So we don't have outflow of the bottle.
Okay.
So and we can do like short fermentation, 24, 48 hours. This system is really good when you have a lot of treatments to screen because it will be a good indicative of fermentation, or if you can measure methane on that system, if you can see some potential, some different doses, because it's really short and it's just like the first step. I think is a very good system to start something that we don't know the answer yet in the field. And then we can evolve to more complex system that we call single flow or dual flow. Single flow is when you have some outflow coming out of the system that will improve how we mimic the rumen, because the rumen is, as I mentioned in the beginning, is like a live organism. And the microbial population there needs like a turnover, a recycling, turnover there. And then if you are getting stuff in and out, you can better simulate the microbial growth that's happening in the animal, happening in the lab. With dual flow, we have liquid outflow that is flowing out, and also we try to create some mat. Like the rumen is not a real mat, but we have some solid part, and then we have solid outflow getting out the rumen. So I have a lot of experiments with batch culture and dual flow. And for the AgNext, I choose the single flow.
okay.
Because, as I mentioned, one big part of what we want to measure is methane.
Mm-hmm.
And with the dual flow, the tricky thing of having outflow, two outflows and measure methane, we have a lot of leakage to the system that we can miss the gas that are being produced and then can compromise our results. With the single flow, we can only have one liquid outflow, and we can really close the system, and it's much easier to measure the gas. And here we are going to have the batch culture for more initial data that we want, or more things that we are trying to really see the potential before going. And then when we are having more advanced data on that thing, we can use the single flow that we can ferment more, and then we can have more like microbial protein synthesis, digestibility, microbiome together with the methane. And also in our system, one thing that is really nice that I never had before, we are going to be able to measure methane over time in a more dynamic way, instead of having like 24 hours fermentation, then collect the gas and only have the total gas. We will also be able to see the pattern of how the gas is being produced over the day with our system. So that's kind of
pretty cool.
That got me very excited with this system here.
It's very interesting. So batch culture, dual flow. Here we're gonna build the single flow, right?
Single flow.
And
with batch culture.
Batch culture, yes, and single flow.
And single flow.
So
Yeah.
I think you've mentioned this a little bit, but how will the AgNext use the system, and what are the questions that you plan to answer? You mentioned the ability to measure methane. So what are the questions that you're trying to answer?
Yeah, so a lot of questions.
Yeah.
But yeah, so like one thing that we are doing in our amazing smart climate facility is like testing different dietary strategies and feed additives. So we have different compounds, like phenolic compounds, that we have a demand to test. But before that, going to our in vivo facility, we want to see the potential and how is the best way to use that. Is more in a grain diet or in a high forage diet. So the idea is first test that, see how it's being acting, like on reducing methane or improving some acids there, that the animal will be more efficient. Also, we want to, the diets that we are testing in the field right now, we want to see how it's manipulate the microbiome. So the idea is to have the same diets that's being tested there, bring to the lab and see how it's changed the microbiome, and then will help us to understand why giving fat to the animal is reducing intake, is reducing methane and improve animal efficient overall. Another thing is like some proof of concepts. We just finished a fat study and we are starting another one that Sara and Maya is going to lead. That some response that we have in the first one was very surprised, and we want to explore more that, like what's the limit of the fat. Maybe like we were taught that after 6-8% would harm the rumen microbiome and fiber digestibility and so forth. So maybe we can go beyond of that. So maybe you can see in the system, let's put 14% of fat and see what's happened with the microbiome and with the methane. So those are things that we are really excited here to use the in vitro.
That's cool.
That is cool. I have a lot of questions.
I can imagine.
Yeah. But one of my most pressing is how soon is the team going to be able to use this? What's the timeline on the project?
So that's very nice. We just bought the equipment that we are going to use here. Arrived 2 weeks ago. So right now we are setting up the system. And our idea is to do a train. I want to train the students that will be involved to use the system. And also I want to learn, because there's something different that I used it before. Then after training the students and learning our system here, I want to do a mock fermentation before our first trial. And this is with the batch culture. And then in December, we are going to start our first trial here, testing 2 different molecules that has a potential to reduce methane in medium and low quality forage. And for the next year, I want to implement our single flow here. And maybe in 1 year from now, we'll have both systems working and producing a lot of data for us and getting out there later.
Yeah,
That's pretty cool. So one of the goals, producing data, right, Sara? so what having this capability at the AgNext mean for the research mission and as well for producers?
Yeah. So I think some of those benefits have already been mentioned, right? But it's the speed and the different scales and the ability to tackle research questions overall in a much more systematic way or much more logical manner, right? So the example of fat is a good one, or other research projects that we're looking at, things where we want to know the optimum dose or get a better dose range before we start feeding it to animals. That's a great use of the in vitro system, is to really understand dosing properly, right, before we go and do something that's expensive. And we're often working with partners in terms of using their animals when we're doing these types of experiments. So we want to make sure that we're making the right choices there. And then, as was mentioned, it also helps us kind of dig deeper into finer details from a standpoint of, well, what are the microbes that are actually being impacted? What are the potential shifts, right? We can answer some of that in the lab as well, and then use kind of our different scales of technology that we have to answer those bigger picture questions when we go out to our climate smart research bins and actually test something on 200-300 animals versus in the lab, first figuring out what should our treatments be, what do we think is actually happening mechanistically, and then from there take it to a higher scale level.
Excellent.
Yes, I love this. I do have a add-on question. So, and that is, as we know, our stakeholders have been very clear, like, do not build what others have. And so one of my questions for you all is, what makes adding in vitro to our group special? How is this stand apart? What makes this system unique and special for the AgNext team?
Yeah, I think it builds upon what I just said, right, where it's connecting those things together, right? And that's what's kind of unique is folks sometimes have in vitro systems at different institutions, or maybe they have somewhat similar facilities to what we have from a standpoint of measuring live animals at scale. But putting those things together, and really the most valuable piece is Eduardo with all his knowledge of in vitro systems and the collaborations that can come from there from a microbiome standpoint, right? So I think that's really the unique piece, is putting all those components together in one location and having a research team that can learn from each other and learn hopefully faster from that standpoint of putting those pieces together.
Yeah, and I can imagine the output of students and their sort of range of knowledge in terms of problem solving and kind of ticking different pieces to the puzzle together could be really powerful.
For sure.
Yeah, as we graduate these students.
Yeah.
Awesome. Well, Sara and Eduardo, thank you so much for joining us today. Been so fun to hear about the in vitro system, and Eduardo, thank you for all of your time and effort that you have put into that system and building it for our team. We can't wait to see the research that comes from this system and all that it advances in our industry. To our listeners, thank you for tuning in to another episode of the AgNext Podcast, where we're always excited to tell you what is next from AgNext. Don't forget to follow us on Facebook, X, LinkedIn, and Instagram. For feedback or suggestions, email us at agnext.colostate.edu.